Hello YouTube, welcome to another video. In today's video I'm gonna talk about neural networks, and I'm gonna show you a little bit of explanation, or I'm gonna talk about a little bit of explanation plus a tutorial on how to create a simple neural network using Pybrain. So let's get started. What is an artificial neural network? They are connectionist systems. There are two types of machine learning. There are two types of artificial intelligence approaches, which are connectionist systems and uh, symbolic systems. Connectionist systems try to figure out the data and learn it. So this is inspired by the biological neural networks that constitute animal brains, such systems learn progressively improve performance to do tasks by consider examples. So we give this system some data, and they learn on how what this data means, or how they can teach us. So here is a simple example of machine learning and data mining. These are two types of things. This here is called a function for prediction, okay, and this one is a function for classification. Let's see what this is a simple. This one is a simple example of how this thing actually works. We have inputs and outputs. This hidden layer, this is called a layer. This is like black blocks. I think there's a lot of things here. Okay, so I'm not gonna learn. I'm not gonna read of this stuff, but actually we have some things like neurons, connections, and weights, propagation function, and basically neural networks are functions. Okay, let's jump into the actual tutorial. I think I'm gonna talk a little bit. I'm gonna use Gianni. Okay, so I think this is going to be very interesting. Let me just okay. I think I'm gonna close this. Okay. First of all, let me just create a Python file. I'm gonna create on documents. I'm gonna create a new folder. Classes. I'm gonna call neural net.py. So what is the process that we are going to do? We are going to do the purpose of this video is to train a neural net. So what do we need to train a neural net? We need data, we need a network, and we need some algorithm to do this. Let's indent this a little bit more. So we need algorithm to train. This commonly is used by a thing called backpropagation. Okay, backpropagation, which basically okay. So we need data, the network, and the algorithm to train, or train algorithm. So this is all that we need. So let's get started by creating the data. Let's create a list, which I'm gonna call inputs. Okay. So how we give the network data? How do we represent this data? So we just can give this network data on our range of 0.0 till 1.0. Okay, so we need to give data in this range. If you are working with images, okay, images have bits, okay, and the bits, when it comes to RGB, they are values between 0 and 255, okay, so you can normalize this easily. If you are working with Boolean values, we are already working with values of zeros, and ones. Okay, so let's work with booleans. But first, we need to create a data set by making some assumptions. Let's create here a table or a matrix. Okay. We can use this for decision making. Let me think here about something that you can use to do this. Okay. Let's create a function for predict when someone is going to buy something. Let's first of all create a table or a row for paycheck day, okay, or payment day. I think this. I'm not sure, but I think you get the idea. Payment day. If someone is gonna receive money, and if they are trying to buy something, if they visited some website, some buyers, I think seller site. Okay, we have these columns, and we have some persons like Maria, okay, Peter, and Anna. Okay, so let's say that buy or not. Let's just create this row. Okay, this is going to be the output. This is going to be our intermediate values. Okay, let's create this data set. So Maria is going to receive money this day. So this is true. So it's 1.0. And it turns out that Maria visited some site. She was searching for some clothes or something like that. This is also true. So she's gonna buy something. So this is also true. 1.0. So Peter is not Peter's payment day. So he's not receiving money. And did Peter visit some site? Yes, he visited some site, but he's not going to buy anything. So 0.0. Okay. So let's work with Anna. So Anna payment day. Did she visit the site? No, she didn't visit any site. Is Anna going to buy something? No. Okay. So this is our data set. As you can see, we have these incomes and these outcomes. So the network doesn't know which factor is more important in order to buy something. But this network is going to figure out this, as you see in this video. Okay, so let's create this arrays. The first person is Maria. Let's translate this. Let's get these two values and put in this Python array or Python list. 1.0, 1.0. This is going to be the features of Peter, 0.0 and 1.0. The last one is going to be the Anna's features, which are 1.0 and 0.0. This is our input list or input array. Let's work with outputs. Okay. again is a list of lists. The first one is 1.0, 0.0, and 0.0. Okay, this is our data set. Okay, if you lack and some understanding here, you can comment down below, and you explain a little bit. I can explain again in another video how this actually works. Okay, but I think you get the idea. If one is going to receive money and they visit the website on the last days, they are going to buy something because they are like trying to look for something to buy. Okay, but like Peter didn't receive money, but he visits some site, he is not going to buy anything. Okay, so this is our data set. Let's jump into our network library. So here we're going to work with Pybrain. We need to create a network. How are we going to do this? We're going to import like from Pybrain.tools.shortcuts. Okay, shortcuts. Import build network. This is our network. Let's import a dataset, which is an object. From Pybrain.datasets, import supervised dataset. Okay. This way of learning, this method of learning, is called supervised learning. Okay. We are showing the data. We're showing inputs and outputs. So we want to then try to figure out what are the best function that represents the data. Okay. Neural networks are functions, so basically it's just a simple explanation. Let's jump into the learning algorithm. As I said before, we are using backpropagation. So let's import Pybrain.supervised.trainers, import backprop_trainer. Okay. So we have the network, as I said before, the data set, and the training algorithm. Okay. Let's create our network object. This is our network object. So in order to create a network, we need to give some parameters. So let's first talk about architecture. I'm not sure if I'm saying this properly. Okay. So the first one is the number of inputs. This network, as you can see here, has two inputs. We have if it's a Boolean value, if it's payment day, and if someone visited some seller site. Okay, this is going to be the two inputs. So two inputs. Okay. The second argument is the number of hidden layers. As you already saw in this Wikipedia article, this is basically a simple network. So as you can see, the hidden layer is usually some number higher the input layer. Okay, so let's insert three. I struggle to speak this number. Okay, so let's the number of outputs is 1, as you can see here. Okay, and neural networks also have something called bias. Okay, let's enable bias by typing bias equal true. Okay, our network was created. Let's create a data set. Let's create a data set by typing DS, which stands for dataset, which is going to be also going to supervise data set. And this data set needs the dimensions of our data set, which are 2 and 1. Okay. We are going to pass this two lists into a Pybrain dataset object. Okay. So we need to add this data here on this DS object. Let's run a zip function, ij in zip, which is going to loop in between these two lists. Okay. Let's call ds.addSample, which is going to add a new sample, and we need to convert this list to a tuple. Okay. So if we came here and work with tuples, it's going to be fine, but we are not working with tuple here, so we are working with lists. We need to convert this into a tuple. Let's call the function tuple. The input tuple output. Okay. So the dataset was created. Let's call print ds just for see if this is right. Okay, let's run this. As you can see, we have this two lists. No, sorry, these two tuples. Okay, so basically is this input and target. Okay, so that's okay. Let's jump into our third part, which is the algorithm to train. Let's create a back, which is going to be equal to back prop trainer. Okay. We are going to train our network, so we're going to pass our net object net and our data set, which is ds. Okay. So this is the training algorithm. So we need to train in something called epochs. Okay, so epochs are like how many times we are going to try. We will try to fit this data set. Usually something around 3,000 works pretty well. So let's run this in a loop for epoch and range. I'm gonna use xrange because I'm using Python 2. Okay, 3,000, and we can call print. Let's call a function. Okay, let's call back dot train. Here we are going to print the error. Okay, this error show us how this network is learning, or how this algorithm is learning the data. Okay, and I think, like lastly, we can just iterate in our data set. So let's again call the functions zip function. Okay, let's compute the values, which is going to be equal net.activate. Activate means run the network. Okay, let's give the tuple. Oh, sorry, you don't need to give the tuple value. Just going to give the I value, and here we're going to print our computed value. So let's say target this value. Okay, target is going to be j, and output is going to be compute, which is the value that we just computed. Okay, let's run this. We have this error, which is become smaller and smaller each time that we run this. Okay, we are running this 3,000 times. Okay, so here we have the output. Okay, let's run what we get. So here the target is 1, and the output for this target for the sample is 0.92. Okay, it's very close. Again, neural networks don't work like exactly. They like return a number which is closer, which is very close. Okay, here the target is 0.0 and the output is 0.04. Here the target is 0.0 and here the output is 0.03. Okay, so we trained our network. Let's create a test. Let's create a new row. New row here. Let's call like Steve. Okay, so let's say that Steve did receive money, and he did also visited some site. So is Steve going to be something? This is a question mark. Okay, and let's say we have Paul, which did not receive money, and maybe he visited the site. Is Paul going to buy something? Okay, let's just create a data set for this. Okay, let's create a new object called people. Okay, this people is going to be a dictionary. Okay, let's create a dictionary. Let's call people.update. We are going to add the name. Let's add Steve. As a key, we are going to add an array. Okay, so Steve numbers or features are 1.0 and 0.0. And let's add Paul. Okay, Paul features are 0.0 and 1.0. The reason that I'm using a dictionary is because we just can give the name of the person and we can just compute it. Okay, so we're not going to let's see here. Okay, let's just delete this. And because we are working with a dictionary now, it's going to be very interesting. Okay, so let's just work here. For person in people. Okay, people. Person colon. Let's see, feature and person features in people.items. Okay. If you don't know Python, you probably need to I don't know, maybe take a tutorial on YouTube. Okay, so we're here we have person plus their features. Okay, so let's compute the result of this person by typing nat.activate features. Okay, as you saw up here, if the number is closer to 1, this person probably will buy something. Okay, if not, maybe we can just like give the probability. Let's represent this like probability. So I think it's a good way to represent this. Let's say that person plus is, let's give the let's create a variable which is prob, which is going to be equal to compute 0, because this array just have one dimension. Okay, one line. We're going to multiply this by 100. Okay, 100. So this is going to give us the probability. So person is, let's work with comments. Okay, is the number, which is the probability, percent likely to buy. Okay, so we can read this like as like probability. Let's run this. If we did get some error, I will explain. Okay. The network is training very well. I think like 1000. Okay. Steve is like to buy. I think I have some encoding errors. Okay. Probably I have some encoding errors here. Let's just multiply this. Let's just print features, and I'm gonna decrement this to 1000 and see how this is gonna work. Okay. Probably let's see. We have these features which are correctly printed. Okay, so this should be the probability of Steve buying. So, but I don't think that's correctly. Okay, let's just see. Instead of printing this multiplication, let's print the actual number. Okay, so you see, but as I said before, like the number will be something like, okay, here we can see this. We can read this like 0.28, like we can just read this through first. After this point, this first number, like the probability, like 28%, like in this like 34% of likely of buying something. These probabilities are still very controversial. Let's add someone which actually is going to buy something. Let's see what we have here. Steve. Let's see what we can do. Let's just add that Peter is going to buy. Okay. Peter visited their site or someone's site and decided to buy something. Anna received money, but she didn't decide to buy anything. Let's just run this again. Okay. So as you can see, the probability of they buying something is not that much. Okay, it's not that high. Okay, but okay, this was the video. If you like it, don't forget to subscribe and like this video. I'm going to make some another tutorials on this library, okay? And probably I'm going to explain further how networks works, okay? So that was the video. Hope you like it. See you later.